Assalamualaikum dear students, I hope you all are doing well. Welcome back to my YouTube channel. Now we are going to continue chapter number 2 and we are going to learn today's topic, that is addition of vectors. Yes, in a previous lecture we have understood regarding scalar vectors, their difference and how we could represent the vectors. Now our next topic is, as I introduced earlier, addition of vectors. Students, before going forward, I would like to introduce or to tell you all that scalars can be added algebraically, while your vectors can be added as well, but having special rules. What they are? The first one is head to tail rule. The second one is Parallelogram Law. And the third one is rectangular components. In today's lecture, we are going to understand regarding the above two, that are head to tail rule and the second one is parallelogram law. Head to tail rule, with its name, it clearly indicates that we have to do something with the head of vectors and with the tail of the same vector or the different vector. Firstly, let's see some bullet points regarding head to tail rule. That here two or more than two vectors can be added. Tail of first vector joins connected with the head of second vector. I hope you all understand this. Now, how we are going to add them? Let's see graphically. This is vector A in front of you all. This is vector B, and here this is vector C. Let's add them. Vector A, this is its tail and this is its head. The tail of the second vector, that is vector B, is connected to the head of first vector, and this is what our head to tail rule is all about. Now, the head of second vector has been connected to the tail of third vector. But here we want just the answer, and their answer is their resultant. How we could have the outcome or the resultant? Here the tail of first vector has been connected to the head of last or third vector. Again, I am telling you all that the resultant is equal to vector A plus vector B plus vector C, that we have drawn graphically with the help of according to head to tail rule, and the resultant is has been taken out by connected the tail of first vector to the head of last vector or the third vector. This is what our resultant all about. Now, the second one is parallelogram. As I told you earlier, head to tail rule we have done with the first one. Now the second one, parallelogram. The difference between parallelogram law and head to tail rule is that in the first one, as we have studied earlier, that two or more vectors can be added. While when we talk about the second one, that is your parallelogram law, here only two vectors can be added. Students, in our primary section we have studied regarding parallelogram. How parallelogram looks like? It's like this. Sorry for the diagram. Let's say this is vector A and this is vector B. In parallelogram, opposite sides are equal. Also, opposite angles are equal. And the last main point is not any angle is of 90 degree. I hope you all understand this. If opposite sides are equal, as we have understood the figure, that means if this side is B, then this side it's also B. Like this, the opposite of this side is this. That's why if this is vector B, then this would definitely be vector B again. And this is vector A. Also, opposite angles are equal. Let's say this is angle 1 and this is angle 2. So, angle 1 is equal to angle 2. In parallelogram law, how we do connect or how we do add the vectors. Let's suppose this is vector G and this is vector F. This is vector F and this is vector G. But these two vectors are not joined or not connected together with the help of head to tail rule. How we could add them now? We should arrange them in a manner to apply the rules of head to tail rule. So what we do in parallelogram? By using the properties of parallelogram, we simply draw a vector G that is opposite to this vector and this is again G. And we are drawing again the opposite of vector F, that is again vector F. Now can you see head to tail rule? The head of first vector has been connected to the tail of second vector. Again the head of first vector is being connected to the tail of second vector. And the resultant will be connected with the tail of first vector to the head of last vector. This is its resultant. Keep in mind that resultant in parallelogram is its diagonal. I hope you understand this lecture. We will continue inshallah in next lecture from where we are leaving from today. If you have any query regarding the lecture, you can write your queries in the comment section. Kindly subscribe the channel, like the video, share the video with your friends. Allah Hafiz till the next video.